So today we'll be repairing a MPPT solar inverter. As you can see, these are the specifications. So the problem we have today is that this inverter is displaying an error code 09, which if you Google it, or maybe if you have the manual and you check, it simply states that the bus start failed, and normally this alarm can only be pointing to one direction, which means that the inverter is probably was overloaded, and then something inside went off. So I've actually opened the inverter. These nuts came out from it. This is the display unit, the user interface. So I already disconnected the screws. This is a module. If you can see inside, you will notice that there's a clip inside that it goes into. This clip here goes into this one here. So this one is used for channeling the draft for cooling. So basically, this is what is inside the SPL 3.2 kilowatt hybrid inverter. And from the look of things, if I can turn this around, first of all, I unplugged this. This is the control switch. Then if I can move this, you will notice there's a burn somewhere here around the MOSFETs. But we are not just concluding on that. We have to run some tests to make sure the problem only stopped here. So let's dig in. Now, after disconnecting this, and the fan and the power switch that came from here, we can safely bring out the panel. If you look where, you will see what happened from the two sides of the MOSFET driver. We can see what happened there. So now, I am now trying to remove the MOSFETs, the screws that are guiding the MOSFETs, and first of all, to remove the heatsink so that I can have access to pull these guys off. So I've removed this. This is the temperature sensor, and this goes here for the heatsink. And I must say, this is pretty small for a 3 kVA inverter. I think it's pretty small, so I think I'm going to upgrade these MOSFETs. An upgrade would be good, but if it doesn't work, I'll find the exact replacement. Alright, so I've removed the MOSFETs, and while I was testing the MOSFETs, I noticed that some of these IGBT, that they are bad, so I had to take it out. There's supposed to be two here. If you look closely, you will see the
hole where it was taken out from. So these ones are for the SPL. So that is just it. These ones are bad. And this one is already bad. This is the other one. I will have to test it and show. So these are the MOSFETs that I took out from the inverter. Sorry about my lighting. I don't have a camera holder. So to test this, you have to put your meter in a continuity mode in diode. I don't know the meter you are using, but my own comes with the diode comes in combination with the continuity. So to test it, you just have to check this leg. Okay, this is an N-channel IGBT. So now to test it, you just have to check the base and the. So if you notice, it has bridged. Normally it's not supposed to be like this. Even this one, the center one, is not supposed to read with the source is not supposed to read with the drain. Now, but this one now, the source is in continuity with the drain, the gate, and the source, which means it's bad. So once I'm able to get the replacement for this, I will change it and we'll continue. So this one now, I went to online to check. This is actually a nice one. It has the ability to transfer up to 140 amps, which is quite good. I don't know if I can get the replacement to increase it to maybe 150 or so, just to prevent what happened before from happening again. So I wasn't able to get the exact MOSFET, but I got a higher one. So this one handles up to 160 amps, but I got the original IGBT. Even though it's not new one, it's used. We are limited by the location we are in. So I'm going to replace them and test so that we'll see. One more thing, I had to remove this because it was blocking the way for me to be able to access the IGBT. So I had to remove it. It's a non-polar capacitor, 300 volts. So I'm done replacing the MOSFETs. And while I was at it, I noticed that there was a 47 ohm resistor. I think it should be a pull-down resistor between the two, the emitter, the source, and the gate of the MOSFET. So these two was bad, and I had to change it because I didn't have a surface mount one. I used the normal conventional resistor. I've changed the IGBT, so the only thing remaining now is to test the inverter and see what comes of it. So I've hooked up the inverter for the testing purpose. I've not coupled it, but I've just hooked it up to check
if our job is okay. So I'm going to turn on the inverter now. So this is the display. I'm going to turn it on. Okay, there was no boom, and the inverter is working. As you can see, it's building up to 230. So I think with this I will test with a load, then we'll know. So for the testing purpose, let's see. As you can see, the inverter is working, so we are good to go.